Okay, so 5.6, we are going to talk about if a function I give you is a polynomial or not, how to know if it is a polynomial. We're going to identify what a degree and leading coefficient is from the polynomial. Then we will do substitution to evaluate a function. We'll talk end behaviors from when I give you a function without a graph, and then you're going to also graph something using, you're going to graph a function using the inspire, finding the zeros using the inspire, and then doing end behavior from that. Okay, it sounds like a lot, but it is really not bad. Okay, so what we're going to look at first is what a polynomial function is. Okay, so it says a polynomial function is a function where a cannot equal 0, so your leading coefficient cannot equal 0. The exponents must be whole numbers. Variables cannot be in the denominator, and the coefficients must be real numbers. Okay, so what makes it a polynomial is something with like examples like this. Okay, as long as your coefficients are real and not imaginary, then something like these examples would be a polynomial. If I had a situation where, say I have f of x equals 3x to the negative 2, okay? So really it says the exponents must be whole numbers, they should be whole positive numbers, because what happens with the negative exponent is that is the same as 3 over x squared. A negative exponent means it should be as a fraction form in the denominator. So if you see x to a negative exponent, that is not a polynomial. Okay. If you see x in the denominator, that's what that means, but not a polynomial. Okay. So what we're going to also have to do is identify what type it is. Okay. So the type it is depends on the degree. The degree of your polynomial is your highest exponent. Okay. So your degree is your highest exponent. Now, standard form is highest exponent down to your constant, right? So once you put it in standard form, your degree and your leading coefficient comes from that first term. Okay? And having it in standard form, that first term will indicate a lot of things, not just degree and leading coefficient, but when we get to end behaviors, it's going to dictate that also. Okay? So if I just have a constant, that's a 0 degree. If I have 5x minus 7, that's linear, that's a first degree. If I have an x squared and everything else is lower than that, that's quadratic. Y'all should be familiar with those. Okay, that's x squared, second degree. Cubic would be a third degree. The only ones that are new for most people are a quartic, which is x to the fourth, or quintic, which is x to the fifth. Okay. You will have to know what these types are according to its degree. So on the test or the quiz that you're going to have over this, I'm not going to provide you with this, so you're going to have to memorize it. Okay, so put a star if you need to, whatever you need to do to memorize that. Okay. So the first two examples we have, it says determine if the function is a polynomial function. If so, write in standard form and state its degree, type, and leading coefficient. Okay. So if I have f of x equals 2x squared minus 3x to the fourth plus 6x plus 1, does that meet my criteria to be a polynomial function? Yes. Okay, so I don't have a variable in the denominator. I don't have anything imaginary, so I am good. So yes, it's a polynomial function. Okay, so then I need to write it in standard form. So if I am looking at that function, standard form would be f of x equals, what's my highest exponent? Negative 3x to the fourth. That 4 is my highest exponent, so that term should come first. And then plus 2x squared plus 6x plus 1. So highest exponent down to your constant. That's my standard form. So once it is in standard form, I can identify what is the degree of that function. What's the highest exponent? 4. And what I always say is if you forget what a degree is, think about when you're actually doing like temperature, okay? If I do like 100 degrees, okay, the degree symbol goes up at the top, right? So if you forget what degree means, just think about that symbol would go at the top, so does an exponent. So that might help you if you forget. Then we have to talk about the type. So if it's a 4th degree, what type is that? Quartic. And then my leading coefficient, my leader comes first, and it's a coefficient. So for the term negative 3x to the 4th, my leading coefficient is negative 3. We good with identifying all of those? Okay. Now on the next one, m of x equals negative 3/7 x cubed plus 7 over x minus 3. Is that a polynomial? Why? This 7 over x makes it not a polynomial function. So you just tell me not a polynomial function, and that's it. You can't identify anything if it's not a polynomial function. Okay, do we have questions over that? We're good? All right, so my next section says evaluate the function for the given value of x. This is very simple. If I give you a function and then I tell you x equals 2, you're taking that 2, bless you, you're taking that 2 and you're plugging it in everywhere there is an x. And I expect to see you substitute that. So I'm going to have h of 2 equals negative, then in parentheses put your 2, and then put your cubed, minus 2 times 2 in parentheses squared, minus 3 times 2 plus 4. Okay? You're going to get a point for that, or 2 points, depending on if this is 2 or 4 points. Okay? So you're going to get credit just for plugging it in. Then from there, you have a calculator. I would take your calculator and evaluate that function when you plugged in 2. Now this section will only be a scientific calculator. That's why I had you keep this, so you're getting familiar with it with this calculator. Okay, so if you type that in your calculator, what is the value of that function? Those of you who are typing it in, make sure you get negative 18. Are we good with that? Okay. So then the same thing for g of x. I want to know what the value of the function is for x equals negative 4. So I'm going to have g of negative 4 equals, in parentheses, negative 4 to the 4th minus 32 times, in parentheses, negative 4 squared plus 256. So type that in your calculator. Tell me what you get. Should hopefully get 0. Okay, those of you who are not typing in your calculator, do you know how to do that in your calculator? Okay. Okay, so now we're going to move on to end behaviors of a polynomial function, okay? And end behavior is telling you where the graph ends which is on the right. So you read left to right, so when I say where it ends, I'm talking about the right side. Okay, your end behavior depends on your leading coefficient sign, the sign of your leading coefficient. So what I mean by that is positive versus negative. Okay, I'll give y'all a second to write that down. So, the expression x with an arrow with a positive infinity is read as x approaches positive infinity. Okay, so what we're going to be looking at is left side versus right side of your graph. Okay, so the end behavior is telling you where the function is approaching as x approaches negative infinity and as x approaches positive infinity. Okay, so x approaching negative infinity, think about your x-axis. Negative infinity, does that go left or right? That would be on the left. And then x approaches positive infinity is talking about your right side of your graph. Okay? So what we're going to look at is what happens when our degree is odd versus even, and then what happens when our leading coefficient is positive versus negative. So if I'm looking and I have an odd degree with a positive leading coefficient, okay, it doesn't matter what your degree is. If it is odd, then notice what happens with these two graphs versus even with these two graphs. What do you notice? Odds go where? Opposite directions, right? I start and end in opposite directions. So that's going to be key. Odd, opposite. Okay. Now, I wrote down that your end behavior depends on your leading coefficient sign. So my leading coefficient for this odd function, this odd degree function, is positive. So that means it's going to end positive. It starts in the opposite direction, so if it ends positive, it's going to start negative. Okay, so it's read f of x approaches negative infinity because it's going down as x approaches negative infinity. So the left side is going down, so it approaches negative infinity. The right side is going up, so it approaches positive infinity. So you're telling me where your y value is going on the left and right side. Okay? Now, if I have another odd degree, but I have a negative leading coefficient, then that negative tells me I'm going to end negative. I'm going to start positive. Okay? So knowing odd opposite is going to be key for this. Now, when you have even, what happens with even degree functions? They go the same. Even degree is the same. They're going to start and end in the same direction. Okay? Now your leading coefficient still tells you where it ends. So if it's positive, it ends positive. But if you know it's even, they go in the same. That also means it starts positive. Okay? Doesn't matter what happens in the middle of your start and end. It's going to start and end positive. Okay? And then if I have a negative, that means it's going to end negative. But since it's an even degree, it also starts negative. Okay? So your end behaviors, you're going to, not these next two examples, but the section after that, you're going to be writing your end behaviors on your own. Okay? So what you need to know is your end behavior will look like f of x approaches blank as x approaches negative infinity. And f of x approaches blank as x approaches positive infinity. Okay, so that's your template And I'm pretty sure I give this to you. I will double check, but I'm almost positive I give you that template. Okay? Now, I go in that order every single time because x approaching negative infinity is the left, where it starts. X approaching positive infinity is the right, which is where it ends. And what tells me where it ends? What did I say? Determines where it ends. The sign of your leading coefficient. Okay, so that's going to be the sign of your leading coefficient. Then to figure out what happens on the left, it's just knowing if it's an odd degree versus even degree. Are they going to be opposite directions or are they going to be the same? It's not hard. Okay? So this first section, I give you a graph, and I'm just asking you to describe, can you look at that and tell if the degree is even or odd? And can you tell me if the leading coefficient is positive or negative? Okay? So it kind of takes what I just told you and puts it in reverse. So if I'm looking at this graph, do you know the degree? Is it even or odd? Odd. How do you know it's odd? Because they're going opposite directions. Okay, what about my leading coefficient? Can you tell if that's positive or negative? It's positive. Why? Because your leading coefficient would tell you where it ends, and it ends in the positive direction. That's it. You don't have to overthink it. Okay? Now this next one, can you tell what the degree is, even or odd? How do you know? They go in the same direction. What's my leading coefficient? Positive. How do you know? Because it ends positive. And because it's even, they're the same. It ends and starts positive. Bless you. Okay, we good with that? Okay, so when we do our end behaviors from just a function, you will not get the graphing calculator for this. Okay? So remember that your end behaviors, we write f of x approaches blank as x approaches negative infinity. And then f of x approaches blank as x approaches positive infinity. Now you're going to write that every single problem, so you're going to have it down by the end of this section, I bet. Okay? So when I know I have to describe the end behavior, I don't even look at the function. I just write my template first, and then I analyze what's happening. So I'm going to write everything out for this problem. And then we're going to look at the function. Now remember, your function has to be in standard form or you're going to mess up. Okay, so that's what you should check for first. Your instructions don't tell you that. Everything has to be in standard form. So if I have f of x equals negative 3x to the 6 plus 4x squared minus 3x plus 6, is that standard form? Do I have highest exponent down to my constant? Yeah. So all I'm looking at is this very first term. And that's it. Right? Because my end behavior depends on the degree and the leading coefficient. So my degree, even or odd? Even. So that means, are they going to be the same or opposite? They're going to be the same. What's my leading coefficient? Positive or negative? Negative. So if it's negative, it's going to end negative, negative infinity. If I know it's even, they're the same, they're both negative infinity. That's it. Okay, so then the next one. F of x approaches blank as x approaches negative infinity, and f of x approaches blank as x approaches positive infinity. Make sure you do your negative infinity first, because then your positive infinity, you know that's where you're ending. Okay? So then I look at my function. F of x equals 4/5 x plus 6x plus 3x to the 5th minus 3x cubed minus 2. Is that standard form? No. And technically these are both x's, so we're just going to tack on a squared on that one instead of combining like terms. It doesn't matter. Okay? Standard form would be what? F of x equals what? 3x to the 5th. Yes. Very good. So that is my function in standard form. So what term am I really looking at? The 4/5 x squared or the 3x to the 5th? 3x to the 5th. If you are not paying attention to standard form, you would have gotten this wrong. So my degree, even or odd? Odd. What does odd mean? Odd, opposite. They're going to be opposite directions. What's my leading coefficient? Positive or negative? Positive. So it's going to end where? It's going to end positive infinity. So it starts where? Negative infinity, because odd, opposite.
Whenever writing the positive infinity, do we have to put the plus, or does the default?
No. No, if you don't have a negative, I know you mean positive. It's just, that's how I learned it, and that's how I've always done it. Okay, the next one is g of x. So g of x approaches blank as x approaches negative infinity. And g of x approaches blank as x approaches positive infinity. Is g of x in standard form? I have my highest exponent down to my constant. So what term am I focused on? What's my degree? Even. So what does that tell me? They're going to be the same. What's my leading coefficient? Positive or negative? Positive. So where is it going to end? It's going to end in the positive infinity direction. So since it's even, it's also starting in the positive infinity direction. Y'all get this? Y'all get the pattern? Okay. Okay, so the next one, f of x approaches blank as x approaches negative infinity. F of x approaches blank as x approaches positive infinity. Is it in standard form?
Yes.
Okay, what term am I looking at?
-5.
Okay. My degree, even or odd? So what does that tell me? It's my leading coefficient. So where's it going to end? Where's it going to start? Okay, I want you to do the next one. For x approaches negative infinity, where's my function approaching? Negative infinity. For x approaches positive infinity, where's my function approaching? How'd you know that? Very good. Okay, y'all get that right? Alright, so do the next one. As x approaches negative infinity, where's my function going? What about the next point? Why is it not negative if I have a negative 2x to the fourth? Not in standard form. It should have been f of x equals 12x to the 8th minus 2x to the 4th minus 6x cubed plus 17. So you have to be careful with standard form. Okay? Are we okay with end behavior? Alright. So the next section, this is going to be with your graphing calculator. Okay, so for your test, you're going to have two parts, graphing calculator versus non-graphing calculator. Okay? So when we are doing a polynomial function, most polynomial functions have an inflection point. Okay, an inflection point is the point where the graph changes direction. Inflection point, we will kind of look at it, but we're not going to focus on it this lesson. We're going to identify it when we do transformations, okay? Now, a local minimum and a local maximum we are going to focus on, okay? So a local minimum is just a low point on the graph. And a local maximum is just a high point on the graph. Okay, so to find inflection point, just take that off because menu 6.5 is something you do in calculus. You don't even do that here. So do not worry about that. And I will show you the mini 6.2 and mini 6.3 in a minute. Okay? So what we're doing is I give you a function. You have to find the zeros from the calculator, the local max and min from the calculator, make a t-chart, and then graph it, describe your end behavior. Okay? So with your calculator, hopefully y'all can see that without the glare. Okay, go to your graph, and we're just going to type in the function I give you. So x to the fourth is all we're doing. Okay, so what we need to do is find the zeros, and then we're going to look and see if we have a local max or min. Okay, so to find our zeros, menu 6, enter. Y'all remember that? Okay, and you have that black dashed line that you go to the left of that x-intercept, which is, you can tell where. 0, you can tell it's 0, 0. But, just to make sure, you go to the left, click your center button, scroll it over to the right, click your center button. So my 0, which is technically my x-intercept, is 0, 0. Okay, now if I'm looking at that graph, am I going to have a local maximum or a local minimum? It's a low point. That's going to be a local minimum. Now in this case, my local minimum is at my 0. So I don't need to do menu 6.2 for me to look at that and analyze that. You should be able to tell that's at 0, 0. Okay? So once you find that, so I don't have a local max on this one. You don't have to have both. Okay? So once I find that, I'm going to build a table. So for your table, you do Control T. So Control T. And I'm going to go as far negative as I can fit it on my graph. Okay, now negative 216 is not going to fit on my graph. If you want to put it in your table, just so you know that's where you're headed, you can. I'm not going to. I'm going to start with negative 1, 1. And then I'm going to have my 0, 0, and my 1, 1. Okay, this one only has 3 points, but you need to have enough that will fit on your graph and give you the curve. You're looking at the graph, so you should know what your graph on your paper should look like. Okay, so negative 1, 1, 0, 0, and 1, 1. Now notice, if I get my table off, Control T gets it there and away. Notice that it's not a sharp turn like a parabola. It kind of flattens out around that 0. Can y'all tell that with your graph? Okay, so when you do yours, you'll hit that negative 1, 1, and then it just kind of flattens out to the best of your ability. And then go back to the 1, 1 and start putting it in the direction of 216. And then we're going to do our end behavior. Okay, so my end behavior is the same. F of x approaches blank as x approaches negative infinity. F of x approaches blank as x approaches positive infinity. Okay, well this one you're looking at the graph, so you can tell they both go where? They both go up, so they both go to the positive infinity direction. And you can just self-check. It's an even function, so they should be going the same. And my leading coefficient is negative, so positive, so they should be going in the positive direction. Okay, that's all you have to do. Very simple. Okay, questions? All right. So go ahead and dock B. And then we're going to do our next function. So go back to your graph. You'll do x to the 4th minus x cubed minus 4x squared plus 4. Now you're going to have a little bit more to this graph. Okay. Now remember, your zeros are your x-intercept. So how many zeros are we going to have? 2. Okay, so menu 6, enter. Go to the left x-intercept. Go to the left of it, press the center button. Go to the right of it, press the center button. So that first 0 is 1, 0. Y'all remember how to move the point so it's not in your way? You'll hover over it, hold the center button until your hand closes, and then move it sideways. And then do menu 6, enter again for your second x-intercept. Okay, that one gives me 2.38. I'm going to round it to 1 decimal place. So what will that round to? 2.4. So 2.40 will be my second x-intercept. Okay. Once you have that, look at your graph. Do I have local maxes and mins?
Yes.
So these little curves that you have are where your local max and mins happen. So this curve right here would be what? Max or a min? A minimum, because your curve is going, that point is low. It's a low point. Okay, but then it comes back up, and so this right here would be a local max, and then it comes back down to another local min. Okay, so we're going to have 2 local mins that we'll have to find, and 1 local max. Okay, so you do the same steps, min use 6, but now for minimum it's 2, for maximum it's 3. Okay, if you just look at your options, you can tell where to go. Okay, so min use 6, 2 will be my minimum. So the same steps, I take that dashed line to the left of that minimum curve, press the center, and then bring it over to the right until you see the word minimum pop up. And I'm going to bring it over so I can read that point. So that local minimum rounds to what? Negative 1.1 and 2. And then min use 6. I'm going to do my next minimum. If you want to do the maximum because it's in the middle, you can. I'm going to do my next minimum. So I'm going to go to that bottom curve and go to the left of it, press the center button, scroll it over to the right, press the center button, and that's going to round to what? Mm-hmm. 1.8 and negative 4.3. Y'all follow me how to do that? Okay. So then for my maximum, I do the same steps, min use 6, but now it's a 3. Do not hit maximum and go find a minimum. Okay? Pay attention to what you're hitting. So that's going to be a maximum. I go to the left of that maximum curve and scroll over to the right, and that's at 0.4. So min use 6 will give you your zeros, your local max, and your local mins. Okay? So now Control T, I need to build my table. And I'm going to go as far negative as I can fit. Now negative 212, it's only 1 point off my graph. I'm going to use that. Okay, so negative 212. Negative 1, 2, 0, 4, 1, 0, 2, negative 4. 322 is going to go off my graph. Okay? So when you graph this, I did not just put the local max, zeros, and mins in my table, but you need to have that to be able to make your graph. Okay? So what I do is I plot these points first. So 1, 0, 2.40, negative 1.12, 1.8, negative 4.3, 0.4, and then I plot the points for my table. Okay? You don't want to miss these on your graph because then you're going to be missing the shape. Okay, so those points I just found from my calculator, I put those on my graph as best as possible. I know you have to estimate where those decimals are. And then I'm going to go negative 212, negative 1, 2, 0, 4 is there, 1, 0 is there, and then 2, negative 4. and then you make your curves. Are y'all good with that?
Is that 2 points on the last, the lowest part right there?
So you have your 1.8 negative 4.3, and then you're going up to 2 negative 4. So they're very close. Just like this point over here, there's technically 2 points here. They're just really close because this one had to be rounded. Then we're going to look at our end behavior. As x approaches negative infinity, where's my function approaching? Positive infinity. As x approaches positive infinity, where's my function going? Positive infinity. They're both going up. Okay, I'm going to move on to the next example. Remember, if you're not done, my copy of the notes is always on Google Slides if you need to go and look at that. Okay? So x to the 5th, so doc B, go back to my calculator, x to the 5th plus 3. How many zeros do I have? I should just have one. So menu 6, enter. Go to the left of it, go to the right of it, and that's at negative what? It'll round to negative 1.30. Now look at your graph. Okay? See how it goes up and then it kind of flattens out and then it starts going up again? These two little bitty curves really are not max or mins. Okay? So it's okay if you don't have a local max or min. I'm just going to put no local max or min. And I'm just going to start building my table. This middle point right here, that 0, 3, that you see where it flattens out, that's what your inflection point is. We're going to focus on that whenever we get to transformations in 5.8. Okay, but that's what inflection point looks like. Okay, so Control T. Negative 2, negative 29 is not going to fit, so I'm going to have to do negative 1, 2, 0, 3, and 1, 4. And I'm only going to get those 3 points plus my 0. Okay, so don't forget about your negative 1.3. And then make your graph, when you draw it, flatten out just like your calculator does, to the best of your ability. Then once you graph that, we're going to do our end behavior. So as x approaches negative infinity, where's my function going? Negative infinity. As x approaches positive infinity, my function is going. All good with that? We have questions? Okay, you will have a quiz over this. Okay? Because y'all do not have Inspires at home, I would look at your worksheet and get what you need. Get your zeros, your max and mins, and your tables. Do those problems first, and then go back and graph it and do everything else. Okay? Use your time wisely. We've got 50 minutes to the bell, so use your calculator first. If you have questions, come see me.